Hello student, I hope your preparation is going good. There is a new part of the thermodynamic complete series of part 6. I have already made a 5 parts videos earlier. So in this video we will continue the last two chapters, that is availability and thermodynamic relationship. So going ahead with the first question, and these questions are the PSU examination question and state like state PSU question or state previous year question. So if you have any further doubt or any other discussion, any other question series, freely mention in comment box. I'll try to make a video based on your requirement. So the first question was the ask in the UP RVUNL examination, and this question is: pressure of steady state and adiabatic flow of an ideal gas through pipe is reduced from pressure P1 to P2. Its irreversibility per unit mass flow rate is given by, they have given T0 is the environment temperature, and you need to basically calculate the irreversibility per unit mass flow rate. Like irreversibility per unit mass flow rate, if you remember that I by M, and if you remember these formula, then definitely you can mark, because you can also observe that T0 into R and T naught R for all the four options are there. You need to deal with these side options. So if you remember that these are the right option, if you derive this formula earlier, then definitely you will remember this formula. If you not, then try to memorize it or try to take a look of derivation. So pressure of steady state and adiabatic flow of ideal gas through the pipe is reduced from the pressure to P1 to P2. Its irreversibility per unit mass flow rate is given by the T0R, T naught R, ln of P1 by P2, where P1 is the initial pressure and P2 is the final pressure. So going ahead with the next question. The next question is asked in the CGPCS Polytechnic lecture examination, and these are the theoretical question. You try to memorize these types of questions. The question is: which of the following is low grade energy? First option was mechanical work, second option was electrical energy, third option was wind power, fourth option of kinetic energy, fifth of heat energy. So we will discuss what was the high grade energy, what was the low grade energy. So basically high grade energy is the energy that can be completely transferred into work without any loss or fully utilized. So basically high grade energy can be completely transferred into work without any loss of energy, that is fully utilization. And the example of high grade energy is mechanical work, electrical work, wind energy, tidal energy, water energy, and kinetic energy. Remember that high grade energy is that energy which completely transformed into work without any loss. And the example for that: mechanical, electrical work, wind energy, tidal energy, water energy, and kinetic energy. For the low grade of energy, energy which can be transformed from one part to the another part, having some loss of energy. In such a case, we will consider as a low grade of energy, like heat or thermal energy. Heat derived from the combustion of fossil fuels, and heat derived from the nuclear fission and fusion. All these three cases are come under low grade energy. If you observe that, then option E is heat energy as a low grade energy, which is mentioned over here. So I hope this video are getting the usefulness of how you can approach these types of question. Going ahead with the next question, which they have asked in APPSC, and they ask this question most frequently in almost every PSU examination. So the irreversibility associated with its process is defined as, remember that these are the most important question of irreversibility. What they have said: the irreversibility associated with the process defined as, they have given loss of qualitative energy, loss of energy, loss of enthalpy, loss of entropy. If you remember the basic formula and basic definition of irreversibility, then you can easily mark this answer. So irreversibility associated with the process defined as loss of qualitative energy, not a quantitative energy. It's a loss of qualitative energy. So option A is the right answer for this question. Going ahead with the next question, which is asked in the same examination APPSC, and they have asked the exergy of the system will depend on exergy. Remember that the word exergy they have mentioned. So option they have mentioned: entropy generation, surrounding temperature, surrounding pressure. If you remember the basic meaning of exergy, then you can get the answer what was the right. So for this question, entropy generation is also the dependent of the exergy, surrounding temperature is also dependent, surrounding pressure is also dependent. So option D is the right answer for this question. Even though they have also mentioned in a solution, exergy is defined as the amount of work of a system can be performed when it is brought in the thermodynamic equilibrium with its environment. it depends on entropy generation, pressure and temperature of the surrounding. They have mentioned it's depend on the entropy generation, pressure and temperature of the surrounding, which is mentioned in the option. So I hope this answer you are getting usefulness, because you continuously revise, you will get the idea how you can get the solution of each questions. So going ahead with the next question, this question is asked in two examination, Rajasthan PSC examination and UJVNL examination. So the question is availability function for a closed system. Remember that the word closed system is expressed as, they have given a 4 option. If you remember these types of question, then you can solve, otherwise it's very difficult because these are the formula based. So availability of a function of a closed system is u plus pv minus t0s. These are the standard formula you need to remember. So right option for this question is A as a right option. So try to memorize these formula, and because these are the standard formula which you need to take care at the time of examination as well. So going ahead with the next question, what is the loss of available energy associated with the transfer of 1000 kilojoule of heat from the constant temperature system at 600 Kelvin, another at 400 Kelvin? They have given the, you need to calculate basically loss of available energy with the transfer of heat is transfer with the 1000 kilojoule of heat from the constant temperature to the 600 kilo, and they have another system as a 400 Kelvin. So when the environment temperature is 300, you need to calculate the what was the loss of energy associated with it. So they have given a 4 options. Basically you need to first write down the data what they have provided in a question, and once you able to find out what was the requirement in the question, then you can easily solve this question. Before that you need to remember the loss of available energy. These are the standard formula, I equal to T0 delta S. If you remember that, then delta S, that is a universe, entropy of universe is written as the entropy of system and entropy of surrounding. If you remember these formula, you can easily solve this question, because they have already given in a question Q value is 1000 kilojoule, and for the temperature T1, T2 and T0 is given 600, 400 and 300 Kelvin. If you put all these data in over here, you will get the answer. So basically T0 is the ambient temperature which is given over here. You need to put the value of Q over here, like Q, what was the heat supplied or rejected over here based on the system and surrounding. And they have also provided the temperature of the T1 and T2 of the both the condition. You need to put and calculate what was the loss of available energy, that is irreversibility for these questions. So at the end you will get 250 kilojoule of loss of available energy. So I hope this question is also helpful to you. So going ahead with the next question, this question is asked in the ESE examination and our most important question, because this question I think recently asked in GATE examination, same type of questions. So the question is the heat reservoir, remember the word heat reservoir, is maintained at 927 degrees Celsius. Sometimes you need to remember the unit of that particular temperature. If that ambient temperature is 27 degrees centigrade, then availability of the heat from the reservoir is limited to, you need to calculate the availability. Before that you need to just basically draw the like questions, draw the pattern how you're gonna approach the question and put the formula and get the final answer. These are the very easy question because are mostly solved within a 30 second. So basically availability of heat is equal to 1 minus T2 by T1. If you observe that T2 is already given 300 and T1 is given at 1200, if you put, you will get the 0.75 as the right answer of option C, which is mentioned in option C in these questions. So going ahead with the next question, which is asked in TN PSC examination. In this question they have mentioned like if a system has a available energy 949.2 kilojoule and change in available energy 1319.2 kilojoule, and effectiveness you need to calculate it. So before that you need to memorize the formula of effectiveness. If you do not remember, then try to write down in a single piece of paper and at least revise 3 to 4 times in a day so that you can remember within a 3 to 4 days. So effectiveness is basically this is the ratio of useful or actual work done to the maximum or reversible work done. That is the basically percentage of effectiveness you can calculate available energy divided by change in available energy. If you go with the question, they have already given the available energy as a 949 and change in available energy is 1319.2. If you calculate the percentage of effectiveness, you will get 71.95. that is the answer for these questions. So going ahead with the next question which they have mentioned, this question is asked in lecture polytechnic lecture examination, and the question is said that which of the following represent the unavailability. If you remember the basic meaning of availability and unavailability, you can solve this question. Basically they have mentioned T0 and delta S are basically formula T0 delta S, but they have mentioned a little bit different. These option is easily ignored because T0 delta S, they have mentioned both the like not in these equations. They do not mention the condition of ambient. This is also T0 delta S, and these option is also neglected. Only option C is the right option for this question. So I think you will get this answer easily if you remember the formula. They have also mentioned unavailability T0 delta S, where T0 is the environmental temperature and delta S is the entropy of the universe. That is consists of the system and surrounding, which they have already explained in these slides. So going ahead with the next question, this question is asked in SJVN examination as an engineer trainee. So the question is says the heat engine received heat from a source at 1200 Kelvin at the rate of 500 kilowatt and reject the waste heat into the medium of 300 Kelvin. What they have said, a heat engine is there at the source temperature 1200 Kelvin with the rate of 500 kilowatt. Reject the heat in the medium of 300 Kelvin. The power output of heat engine is 180 kilowatt. What will be the irreversibility of the system? You need to calculate the I for this system. So if you remember the formula, you can easily solve this question because these are the very little and chimbo questions. So basically efficiency of Carnot engine, if you remember that they have asked for the question. So you need to basically put the value of T2 and T1, which is mentioned in already question over here. And for the 300 and 1200 is given T2 as a T1 temperature, and Carnot output is given as a input. They have given as a 500 joule. So if you put all these data, like basically what they have said that if you multiply these equation, like output is equal to input into that bracket terms, which is 1 minus bracket term, which is 1 minus T2 into T1, which they have mentioned over here. If you multiply these equation over here, you will get the input as a 500 and T2 as a 300, T1 as a 1200. You will get the Carnot in output as a 375 kilowatt. And to calculate the irreversibility of the system, that is Carnot output minus actual output, which you remember this formula earlier. So if you put these data like 375, which is calculated over here, and these 180 is already given in a question, that 180 actual output is given. So you will get the irreversibility of the system as 195 kilowatt. This is the final answer of this question. Going ahead with the next question, which they have mentioned in ESE examination, and this question is asked most of the like PSU where the numerical question are more. So the question is said for the steady state process, the condition at the stage 1 and 2 are respectively, they have mentioned H1 kilojoule per kg Kelvin, H2 150 kilojoule per kg Kelvin, similarly S1 1.25 kilojoule per kg Kelvin, similarly S2 is 0.850 kilojoule per kg Kelvin, and availability at the ambient temperature of 300 Kelvin will be. They have given a 4 option, and if you observe that the solution, then they have easily put the formula and get the answer. If you remember the formula, you can easily solve. They have given H1 H2 T0, similarly S1 and S2. If you remember the availability formula, you can put H1 minus H2 minus T0 S1 minus S2. If you put all these value, you will get the final answer of availability as 15 kilojoule per kg. This is the final answer of this question. These are the last question for the availability chapter. So the last chapter was properties of pure substance, gases and gas mixture. So the first question is asked in BHEL ET examination, and these questions are most frequently question of most of the PSU examination. So the first question was the equation which perfectly represent the Gibbs phase rule for a process where the pressure is also a variable expressed. There are few conditions in the Gibbs phase rule, so try to memorize these equations. So basically these are the standard equation which you need to remember it, and if you remember, then you can easily solve this question. So the question which they have said that the Gibbs phase rule is P plus F equal to C plus 2, where P is equal to number of phase, C is equal to number of chemical component, and like N is the number of non-compositional variable, and H is equal to the what was the variable, that is pressure and temperature, F equal to degree of freedom. These are the solution for these questions. So the next question is, so basically the next question is asked in SJV and ET examination. So this question is related to the Gibbs free energy. Last question Gibbs phase rule. This question is related to the Gibbs free energy. So remember these two terms. These are the little bit confusing, so try to memorize these two equations, because these are the, if any of the question they ask related to this, then definitely you are not able to solve if you do not memorize these types of. So what was the relationship defined between Gibbs free energy? So if you remember the formula, you can solve this question like G equal to H minus Ts. These are the standard formula for the Gibbs free energy. So going ahead with the next question. This question is asked in a BPSC examination. The Clausius-Capron equation gives the slope of the curve. If you remember the Clausius-Capron equation, then you can easily get the what was the conclusion of the slope curve. That is the PT diagram for this, the slope curve of Clausius-Capron equation. If you do not have idea, try to memorize this equation, and what was the inference which you will get from the equation, and also from the diagram, try to memorize these two inferences over there. So Clausius-Capron equation is dp by dt hg minus hf into p divided by r into t square, and it also gives the slope of pt curve. These are the standard inferences which you get at the time of derivation of Clausius-Capron equations. So going ahead with the next question. This question is asked in RPSC AE examination. This question is said about that the statement that molecular weight of all the gases occupy the same volume is known as, this condition is known as the Avogadro hypothesis. If you remember this, the molecular weight of all the gas occupy at the same volume is Avogadro hypothesis. So for this question you can consider the A as the right option. This can also be mentioned over here. The statement that the molecular weight of all the gas occupy the same volume is known as the Avogadro hypothesis, which I have already explained you in a previous slide. So going ahead with the next question, OPSC, they have asked this question in OPSC examination AE. So in a single component condensed system, if the degree of freedom is 0, remember the degree of freedom they have mentioned as 0, and they have mentioned the component as a 1 single component, P plus F equal to C plus 2. This formula you need to use. So maximum number of phase, definitely I'll say that maximum number of phase that can coexist. If you remember that P plus F gives phase rule equal to C plus 2, which I have just explained you in a previously slide. So if you remember that this component they have mentioned as 1, they have mentioned degree of freedom as 0, and they have mentioned as 1, you need to calculate what was the maximum number of phase. So if you put these value, like degree of freedom is put, you need to put it as 0, and component put it as 1. So 1 plus 2 equal to 3, that is D is the right option for this question. If you put, similarly they have solved in this slide as well. If you do not understand, you can get the solution over here as well. So going ahead with the next question, which is asked in OPSC examination again. Then water vapor can be considered as an ideal gas. What was the condition? So make sure that you need to remember these types of question. So the water vapor considered as the ideal gas as a low pressure. These are the basic assumptions you need to consider while considering the ideal gas behavior. So you can mark this as a at low pressure, that is answer D, which they have mentioned over here as well. At very low pressure and high temperature, all the gases and vapor approaches to the ideal gas behavior. So make sure that the condition was low pressure and high temperature. Going ahead with the next question, which they have mentioned in the TNPSC examination. The question is said that they calculate the dryness fraction. You need to calculate the dryness fraction of the steam which has 1.5 kg of water in the suspension with 50 kg of steam. So mass of vapor they have given as a 50 kg, and they have given 1.5 kg of water. So basically you need to calculate the dryness fraction. If you remember the formula of dryness fraction, that is X, you can calculate MV, mass of vapor divided by mass of water plus mass of vapor. If you put all these data in this formula, then you can get that MV is already given 50 kg and mass of water is already given 1.5 kg. Similarly 50 kg for the mass of vapor. If you put, you will get the dryness fraction is 0.971, which is option A for these questions. So I think this question is also clear. Going ahead with the next question. So the next question is asked in TNPSC examination. This question is latent heat of vaporization of water at critical point is. So latent heat of vaporization at critical point, they have mentioned that. If you remember that the latent heat of vaporization for water at critical point is 0. If I think you may remember this point, because these are explained at the time of pure substance graph. So if you remember that, you can easily mark this answer over here, because these are the latent liquid, saturation liquid and saturation vapor curve, and there are the latent heat of vaporization at critical point, and you can consider as that particular critical pressure at that time 221 bar, and temperature of that particular critical is 374 degree Celsius for this condition. So you can mark that answer accordingly. So going ahead with the next question, which is asked in same examination, the heating of a gas at constant pressure, remember that the word constant pressure is governed by, if you remember all the law, then you can easily observe which law is deals with the constant constant pressure. If you do not remember, then try to memorize these types of standard theoretical questions. So the Charles law deals with the constant pressure, Boyle's law deals with the heating of gas at constant temperature, and Gay-Lussac law deals with the constant volume. Remember that Gay-Lussac deals with the constant volume, Boyle's law deals with the constant temperature, and Charles law deals with the constant pressure. So accordingly, you need to mark as a answer for this question as a Charles law for the constant pressure. So this is considering almost we have covered all the question of all the 6 chapter, and these questions are coming from the almost all the PSU examination, and almost whatever question which I have selected, these are at least come twice thrice in examinations. So try to revise all these question before going to any of the PSU examination, state examination, and if you find anything irrelevant, just let me know. I'll try to remove that part, and if you need any like addition of this material or any other subject, try to mention in comment box. I'll definitely make a video as soon as possible. I hope this video are helpful and informative. If you think, then do like and share with us and subscribe this channel. Thanks for watching.